Welcome to Chapter 7, Ionic Equilibria, Buffer Solution. First, let us define buffer solution. Buffer solution is a solution that undergoes a limited change in pH upon addition of a small amount of acid or base. The acid and base that make up the buffer, however, must not consume each other through a neutralization reaction. These requirements are fulfilled by a weak acid-base conjugate pair such as ethanoic acid and ethanoic ion, ammonium ion, and ammonia. Okay, for example, this is an acidic buffer solution. It contains a mixture of weak acid and its conjugate base. Okay, for basic buffer solution, it is a mixture consists of weak base and conjugate acid. The acid component of the buffer can neutralize small added amount of hydroxide ion from strong acid, and the basic component can neutralize small amounts of added hydronium ion. Okay. Next, let us learn how to write the Henderson-Hasselbalch equation for a given buffer solution. There are two types of buffer solution. One is acidic, another one is basic. Let us look at acidic first. An acidic buffer solution is a buffer solution with pH less than 7. So it's made from a weak acid and one of its salts. Okay, often is sodium salt. Okay, for example, we have ethanoic acid and sodium ethanoate. Okay, so the conjugate base comes from CH3COO-Na. Henderson-Hasselbalch equation. So it's the same thing. We want to calculate the pH of the buffer solution using Henderson-Hasselbalch. We cannot straight away use pH equals to negative log H3O plus. Okay, we cannot use for this because it is a buffer solution. So what we do is we use pKa log conjugate base over weak acid. The same goes for basic buffer. It's a buffer solution with pH more than 7. It is made of weak base and its salts, for example, ammonia and ammonium chloride. So for basic buffer, we calculate pOH. We do not use negative log OH minus. We use Henderson-Hasselbalch equation to calculate the pOH of the basic buffer solution, pKb plus log conjugate acid over weak base. Okay, now let's look at what are the equations that involve in the buffer solution. Okay, first we have weak acid. Okay, so weak acid, we know it will dissociate partially in water. Okay, and then another one, we know that we have salt. Okay, so the salt will completely dissociate, and then we will get the conjugate base. Okay, now another one, how do we know that it is an acidic salt? Because the conjugate acid the conjugate base will react with water or hydrolysis and then will produce again weak acid. Okay, so remember to calculate the pH of a buffer solution, we use pH equals to pKa plus log conjugate base over weak acid. The same goes for basic buffer solution. First, we have dissociation of weak base. Okay, weak base dissociate partially in water. And then we have salt, the dissociation of salt, That's why it's completely dissolved. So we have single arrow only. And then how do we know that this is a basic salt or acidic salt? Is through the hydrolysis. Okay, so to calculate pOH, we use pKb plus log conjugate acid over weak base. Okay, now let's look at one example. Write the Henderson-Hasselbalch equation for the following buffer solution. Okay, first of all, just now remember that in this slide, salt is usually a sodium salt, okay, often a sodium salt. Okay, so this is a sodium salt. Okay, so if this is a sodium salt, this is a weak acid, so this will be the conjugate base. Okay, so the conjugate base, we use the ion. Okay, and then H3PO4 is the weak acid. Okay, thus we know it is an acidic buffer solution. So we substitute into Henderson-Hasselbalch equation, and this is the answer that we get. Okay, another one. Okay, let's look at this. Okay, this is a weak base. Okay, how do we know that this is a weak base? Okay, because there's nitrogen. Okay, then another one is the one with negative. Okay, so this one weak base, so this one will be the conjugate acid. So to find the P, before we find the pH, we need to look for pOH first, because this is a weak base. So weak base is the same, log conjugate acid over weak base. Okay, so that's all for acidic and basic buffer and how to write Henderson-Hasselbalch for acidic and basic buffer solution.